Oh. Here, what are they watching? What is it?
I know, it's not like DNA and just.
I guess it's next door. I don't know. Okay, so technology around here is a weird thing. So I brought all of my own technology. Unfortunately, the network won't let me in, so I'm going to have to go back to this, which is okay. The problem is it's tied to this only, but that's okay. So, oops, didn't mean to hit that one. I meant to go over here, hit this one, add a tab, go in here, log in. And I already did this. Okay. Since the technology of every room is so vastly different than the other room. Okay, so I think we were bailing around. Were we in 4? I can't remember. Yeah, there we are. So I think, I don't know if is the aspect ratio there okay? It looks funny on my screen. I didn't do that one. Where's the one that I did? Is it in this section or is it in 3? Here, let me go back. Maybe it was in 3. Oh, I think it was. Okay, there's the one I did. Let's go look at this one. Now, of course, I'm assuming that everyone has looked at the videos there. So let me just go ahead and grab this thing, drop it over. Yeah, copy to clipboard. I'll create a new page. I'll just drop it right there. Okay. It won't. Okay. There we go. So I can zoom in or out of the thing. I can make this. I don't know, tell you what I did in the last class. So I brought the stream up so I can see it without the sound. So let me turn the sound off. So I can see it right there. Okay. So about 4 or 5 seconds behind on that. So now I've forgotten what he was asking. Determine the coordinate direction angles at F1. Then he wants to add them together. Then is there a third one? No, there's not a third one. So he wants first for you to find the coordinate direction angles at F1. So unfortunately, let me go back to the live stream, see if I can add, let's see, Windows capture, video capture, I see the windows, display capture, let's do a display capture. That looks like that is the entire display. Okay, so that's fine. Let's see, window capture, I'll drop it out. I think the audio capture is still there. So when I get rid of this, say I can look on the phone and 5 or 6 seconds later it shows up. I'm going to use MATLAB to get through this problem. Okay, I think we're okay. So let me hit the OneNote and just start doing it. I think the pen, okay, now wait a minute. You gotta get to draw and use yourself a, here, just try that again. Just use a blue, see if this thing works. Okay. So he wanted to know if F1. So I can't touch the screen and make it grow, so I'm kind of stuck with it. So what you've got here is kind of a light blue and then a dark blue. And what you gotta imagine here is there's a sun sitting up here, projecting rays and creating a shadow on the ground. On that shadow, you see a vector that's right there, which actually, if I hold the control key down, I can zoom in on it a little bit more. So the length of that vector, it goes through the 60 degrees, so it's 300 times cosine of 60 degrees. That's this vector right here. Now, unfortunately, let's see, I found out if I hit if I hit that key, I can go in here and hit an erase. So at least I have that. I use my left finger for the Alt key under my right hand. I still don't have a way to move the things through here, but that's okay. So that, in fact, is the length of the vector that is the shadow, you could say. Now, you could, and I'll go ahead and do this, it's easier to do at the house because I have better facilities there, but if I take that image and bring it up to here, what you see is essentially a square that's in a plane right there. And you can look at that as being a plane. So there's a component of this vector that's going straight north or straight up the z-axis. Well, that one is actually going right down an axis. So the component of that vector F1 in the z it's still 300 is the length. And this time, instead of going through the cosine of 60 degrees, it's going through the sine of 60 degrees. Meaning if you turned off and look at this thing, you'll see this is the triangle, but if you took this thing, did a copy and a paste, moved it out there, it would be the component right out there. So that would be the same, those two vectors are the same thing. So this one is the same thing, 300, whoops, Alt, give me back this would be 300 sine of 60 degrees, if that makes sense to you. Once you do that, you have your two components. The thing is this one goes directly in the z direction. This one is laying on that plane. And what you have to do there is you have to begin to look at the drawing by itself. And I would attempt it if I could get my surface to working, but essentially what you're looking at now, oops, let's go ahead, go back to what you're looking at now is this triangle, the one that's laying on the ground. And the one that's laying on the ground, you have to kind of stare at it for a minute. It doesn't look or appear to me to be actually 45 degrees, but, you know, it kind of is. And so it sounds weird. If it's 45 degrees, this length is the same as that length. And that, to me, visually, that doesn't look to be the case. But, you know, maybe it's the fact that it's a projection, maybe. But we'll just go with that for the time being. And what we'll realize is we're looking at the length of this and the length of that. They both should be the same, Because if you look at a triangle which is 45 degrees, I'll erase this in a second. So here's a 45 degree where this is 45, this is 45, and of course that's 90. Then you'll get this length over here, but these two lengths will be exactly the same. And so what you'll see is sine of 45 is equal to cosine of 45, which is equal to 1 over square root of 2. And you could work that out if you wanted to, but we won't do that right now. So that being the case, you take the length of this, 300, cosine of 60, and then you're going to put them over the square root of 2, and that will be the length of the vector in both the x and the y directions. However, what you see is it goes in the negative x direction. It goes in the positive y direction. So to list this thing out now, you have to kind of, I can shrink it down in a second. It was vector 1. I'll go over here, I'll list it out as I plus j, and then plus that times k. Now, what I'll do is hold the control key down and shrink it back down. So this one is the z component, goes directly north. And so that one should just sit right here. 300, 300 sine of 60, sitting right there. This one sits in both the x and the y. However, it sits with a minus sign right here because it's going in the negative x direction. So it's 300 cosine of 60 over square root of 2, and this is 300. Sine of 60, I guess you could say, over square root of 2. But they're both, I'm sorry, excuse me, that should be cosine. Here, let me hit the erase. So they both should be the same, but in the negative, each one in a different direction. So what I'm going to do, bring up this, maybe shrink it down a little bit. You can double click here. Wait, you used to be able to. Get rid of that. Wait, double click it again. Okay, so now it occupies just the command window, occupies everything. It's kind of oversized, but that's okay. So now I got to get the keyboard up here. Okay, so I'm going to basically list it in its component direction. So I'm put it in the vector. So vector 1, 2, 3. So it would list that way, but that's not what I've got. So I've got to fill these out, and what I've got is minus 300 times cosine. Did I type that right? Degree 60 divided by square root of 2. Now we'll do one in a minute that's not 45. And then, hey, I'll just make use of my copy and paste. And then I'll do the 300 sine of 60. And if you get that, you see, you know, F1 is minus 106, 106, and then 259. First thing to check is let's check the norm. The length of F1, 300. Well, that's good because that's what we started with. The thing was 300 to start with right here. So it's 300 up here, so that's good. Glad to see we got back the same length. But now he wants to know the direction, didn't he say, let me go back. I forgot exactly what he was asking. Determine the coordinate direction angles of F1. Okay, let me go back. I'll go back to the page here. And then I'll list these things out. So minus 106, 106I plus 106J plus, I think it was 259 and change here. 259.8. Okay, so this is your F vector. So let's play around with how you get the direction angles here. So, you know, I'll do, let's do it this way. Okay, Alt. Okay, I'm on here, Alt, okay. Is there, let's see. Okay, so what I'll do is do a copy. And I'm going to drop down here and do a paste. There we go. So I'm taking the same picture because what I want to do here. Now, let me copy that thing. Come on. It just wants to move the page. I don't know. Anyway, so what I've got here, hit the Alt, go back to it, is I want to find the unit normal that goes up that vector. And this is actually pretty important, you'll find out later, that this vector is unit length. And I'm going to call it UF1. And so all you do is UF1 is just equal to the vector itself over its own magnitude. And all this is, you can just type in MATLAB norm of F1. But the norm of F1 is equal to 106 squared plus 106 squared plus, come on. People calling me. I'm not that important. Okay, 106, 106, and 259. And so that's what the norm will give you. It's just so convenient to type in the word norm and put parentheses F1 and you get this number, which actually in this case was 300. So let's go back and figure out what that vector would be. And I already typed in the norm and the norm was 300. So let's go back and fill out the final thing. U F1 is equal to F1, which is the whole vector, divided by the norm of F1, and hopefully I typed that correctly. To prove this is the case, that we've done this, we'll look at the norm of F1, and it gives you back 1, which is like saying who's buried in Grant's tomb. Essentially, I forced it to be of length 1, and we go look at it, and lo and behold, it's length 1. So those are my three numbers. And let's see, 3536. Okay. So minus 0.3536I plus 0.3536J, and I have forgotten the other. So 866. Oh, that's 866K. And that's the norm. Now, if you go back and look at the lectures we already have, and or, let me see if I can find this. I found it in the last class period. Let's see, did I? Okay, it may be the old edition, but it doesn't matter. They all say about the same thing. Oh, geez, it's loading from the library, so. Okay. Okay, come on. All right, there we go. And for some reason, let's go down to, I have to kind of, not there yet. This is not the best way to view this. Okay, so there's the shadow vector, so to speak. The sun hits the A and it creates the shadow on the ground, and then you use the theta to find the X and Y components. But I think after that is where they break it. Oh, it may be the next section. I thought that that section was before it. I may be right. I think that section was before that section. Roll, roll, roll the mouse. Wait a minute, where did it go? Did I go right past it? This is 2D. Okay, there's the components. There's the X, Y, and Z. Oh, here it is. Okay, so what he's doing here, he says, it looks like it is written slightly different here. You have the Z component of the vector A, the Y component of the vector A, and then the X component of the vector A. Then what he's saying is if you look at it, for example, I don't know, can I write on the screen? Let's try. I'm going to push this button and see. Nope. I don't know what that button does, but it didn't do what I want it to do. But what I can do, this, okay, I can grab this. Oh, it created a funny thing there. Copy the clipboard. If I now roll down past that, how do I get that stupid thing out of there? Okay, it's not available, but I want it to go away. Go away. It looks like it's, okay, well, it looks like there's going to be some funny little disc stuck there, so we'll move that out of the way. We'll go right here, shrink it down, and look at it like this. Okay, if you stare at this thing, this, actually I should have done it slightly differently. Let me hit the, let's see, Control Z will take that off. Control Z off again. Let's look at it this way. It's going to take a little bit of getting used to. If I draw a vector between here and here, oh, and I wanted it to be a straight line, and then go down to here and here. This is actually a plane. If I got perpendicular to that plane and looked at it, you would realize that this is the angle because that is a triangle that is leaning over out of the XZ plane, and it's still 90 degrees down there. So what you'll find out is if you're taking the cosine, it would be, in this case, it would be this component over the total length, which is this one. Meaning, if I sort of was right here, staring up at this thing, what this little red person would see would be this. Doesn't look very good. Where this would be the AX, this would be the 90 degrees. The angle that's tilting here, it's hard to see because it's stuck right there. It would be this one, and that'd be the A. And so it takes a little getting used to. Here. But each one of those you can imagine as being a triangle because, and it is a triangle, and each component makes up a plane. And it turns out they all follow this same kind of concept, you know. If you're looking at something You're looking at some length here, in this case, I guess you could call it A. And then you have some angle, say 60 degrees, and this is going to be the cosine of the 60 times that. So it's the angle that you're moving through. So that's why they're called direction cosines. And if you stare at them real quick, you'll realize, hey, wait a minute, these actually are the components of the unit vector that we have sitting right here. So the nice feature in MATLAB is that's easy to come up with because I got them all listed right there in this vector. It's named that. So all I have to do is do arc A cosine. Uh-oh, what happened here? Let me see, did that phone call mess everything up? It did. Hang on. Stupid people calling me.
Where's the spam follow?
Yeah. Okay, we're back in on the stream. So it broke the stream on my phone. It didn't break the stream here. So I have that. So now I'll just do A arc cosine. I want the answers in degrees, and it's off of U. What did I call it? F1? F1. And there's my three angles. 110. Here, I'm going to do this. Do a Control C. And I'll just, I don't know if this will work. Oh, it does. So it works. This is a little bit slightly different than, so these are the answers from taking the cosine inverse of let's say minus 0.3536, 0.3536, and 0.866. And this is the X, the Y, and the Z. And so my angles, alpha lines up with the X, so it should be 110.7 degrees. Notice it's larger than 90. And if you look at the picture, it's the X component runs in the negative direction. So this angle from here to that vector is going to be larger than 90 degrees because that vector breaks through this plane and is pushed back behind it. If that vector lay in that plane, it would be 90 degrees. If the vector is behind that plane, it's going to be a little greater than 90 degrees. Beta is going to be 69 degrees, and then gamma is going to be about 30 degrees. And I believe, I hope, I attempted to, I thought I did. Yeah, I put the answers in there. And I put them in there just to give you a guide to work towards them. 111, I don't know, what did I get? Yeah, 111, 69, and 30. But I don't know. 60. Now, why he didn't carry digits there and he did here, I don't know. And then the other is 30 degrees. Oops. Yeah, here you go. 30 degrees. 30 degrees, 69.3. 110.7. I don't know. So that's pretty much it for that one. The next key is that now we have this, we can slide that to the side and do something interesting, and that is associated with the next problem. Same exact picture, same exact everything. And then he says find the magnitude and the coordinate directions, angles of the resultant force. So he's wanting to add those two together. So how do you do that? Well, now you got to break that apart. Let's see if, okay, I don't know. Let's try to grab that again. Do a copy, and we'll do a paste. And I don't think I get to move it. It doesn't allow me to move it. So now you turn around in reverse and use the, okay, Alt. This is very obtuse handling this. Especially since I can't see part of the bottom of the screen there. And the other thing is, okay, it doesn't appear until you write past that, and then you can slide to the side. That is an artifact of the older. So, in other words, if we want to find the magnitude of this thing, I have exactly the alpha measured from the vector and the x-axis, exactly the beta, and I actually have, he gave me the actual angle relating it back to the positive z-axis. So that's pretty easy. The vector f2, nothing more than 500 times cosine of the alpha, or 60 degrees I, plus cosine of the beta, or 45j, and then plus cosine of the 120 and the k. Now here's what's so interesting about that. If you look at it, this vector points below the xy plane. Therefore, it's going to have a negative component in the z. If you look at the cosine of 120, that's exactly what you get. Here's 90 degrees. Here's 0 degrees. So here's like, I'm just making it up. There's, where did that come from? There's a 120. There's, say, 180. There's about 120. So it's going to be a minus number. Don't know what that number is yet. So in fact, that's going to give you a negative number. That's going to give you a positive number. That's going to give you a positive number. So the fact that it drops below this plane is okay. Okay, is this a situation where I can, yeah. Okay, so heading into MATLAB, I can just make use of that and put in F2 is equal to 500, and then I'll put a times, and then put the bracket, cosine degree 60, oops, cosine degree 45, and then cosine degree of 120. Okay, 200, and then 250. 353, you know, I was able to copy that last time, you know, and I know that it ends up kind of small on the page, but here I'm going to drop it right there. And then I'm going to rewrite under it. It'll just be so that I don't have to look back on the previous page. So F2 is going to be 250I plus 353.55J minus 250K. So yes, it drops below the XY plane. So if, okay, I'm not a great drawer, but I'll make a half-hearted attempt at this. If I were to draw the box, so to speak, that this vector sat in, well, that's pretty lucky. Okay, so then I got to run this up here, and then I go across. That's okay. That's not a great box, but it's certainly not to scale either. So first, 250 in the eye. So that means this box is 250, or 250 here. It goes down 350. Then this, look at this, totally out of scale. So it goes down 353. So this dimension of this box is 353. And then this, I'm sorry, that's the wrong dimension. Hang on. Okay. That's supposed to be, whoop. This one is in the, well, you know what? No, it's not even close to scale, but okay, so it runs out in the y direction, 353. It's not to scale at all. And it runs down, the box runs down 250, so this dimension's 250. So again, that is in the K direction. That is in the J direction. And that one's in the I direction. Or this one's the same one. Does that make sense? It's just, but the box is not to scale, nothing, this distance looks a lot smaller than that, and it's, I mean, it's okay, It's hard to draw these things perfectly to scale. I think these days, I mean, this book was written so long ago that artistic renderings were just artistic renderings. Nowadays, you can find all sorts of CAD things to draw those to scale and look, but, now there's very small desire to do that. Okay, so if I slide this one, let's see if I can use that. Okay, so what I'm going to do, I'm going to use the lasso. I'm going to grab, I'm going to grab this equation. I'm going to do a copy, come back up here. I'm going to try to slide across to here, and I'm going to drop it right there. So now what do you want to do? Well, you want to add F1 to F2. So you add this component to that, this one to here, and that one to there. Well, that's interesting. I can do that one by visual sight, but I don't know about the rest. So I have both of them, I believe, stored on, I think I have both of them stored here. Let's just type F1. Do I have F1? Do I have F2? I have both F1 and 2. So I'll say F resultant equals to F1 plus F2. How did that end up there? Anyway. So, I think I'll do this again. I think I'll just do a copy so I don't have to look back and forth. And I'll just drop them right there, say, oh, that's interesting, they moved over there. So if I did F1 plus F2 and called it the result R for resultant force, I would get from these two, I would get 143.9. Does that look about right? So 150, now you have to remember, I wrote this down, but I threw away some of the digits. And that's I, and then 459, so that's 353 plus the 106, that's about right. 679, yeah, that's right. 459.6194, and then I took that 250 and knocked the 259 off of it, which give me, I'm sorry, 259 minus the 250 gives me plus 9.8 K. Now, the magnitude. The two things that I believe he was actually looking for was the magnitude and the coordinate directions. So, okay, so he did F1, F2. So there's a 144, 460, 9.81. That's about what I got. His was 144, mine's 143.93, 460, 459.6. 9.81, so we're about okay there, but how do you get the resultant and the angles? Because that's sometimes the most newest part, so that's pretty easy. First, you find the unit vector, which is FR over the magnitude of FR. Now, we can do that with one statement in MATLAB. Then what we do is in MATLAB, we take the inverse cosine of the vector use of all FR, and we get the components out. We'll get the three angles, the alpha, the beta, and the gamma. So let me do that real quick in MATLAB. So first thing I'm going to do is I'm going to go after, and this unit vector actually has a lot of significance later, because Well, we'll see why, but if you take a cable, attach it to a boat and pull down the cable, or anything, attach it to a pole or anything, and you're pulling down the cable, you're pulling in that direction. And so you want to know the direction you're pulling. And that's where this unit vector is going to give you. FR. FR divided by the norm of FR gives you a vector which should be of unit length. So, let's see. Let me scroll. Oh, it won't let me scroll. Okay. So that is the unit vector. I'll tell you what, let's just copy that. Copy. Go over here, and I'll sort of drop it right there. So that's what that vector is. That vector is 2.2988I plus 0.9541J plus 0.02, kind of small, K. Apparently, when you get close to the edge of the screen, it doesn't work very well. So those are the components right here. Next, I just take the inverse cosine in MATLAB, and it gives me back the three angles. Arc, cosine, I want it in degrees. U, F, R, gives me my three angles, 72, 17, and 88. I'm going to do the same thing. I'm just going to copy it. Okay, so there they are. I know how to do it in my Surface tablet, select those and move them, but I can't right now, and that's really bizarre. I think that's an artifact, but it's stuck and I can't get rid of it right now. I think if I hit F5, I'm scared something else weird will happen. So in other words, alpha is equal to 72.6 degrees, beta is equal to 17.4 degrees, and if I go down, gamma is equal to 88.8 degrees. Let's see if that's what. 72.6, 17, and 88. I just remember the last. Oh, I know. Here we go. 72.6153, 17.42, and 88.8334. So that's pretty much it. So what I'll do, today's Wednesday, I'll do this other problem on Friday in the live stream. And then what I'll do, let's see, I'll go ahead and do, wait a minute, this is 268 and that is 263, right? So I'll go ahead and do these. 1, 2, 3, and then, so this one is a key problem because this is where the unit normal becomes very apparent why you need that unit normal. So I'll definitely do that one. That is an absolute. The directions are given to you. But this one starts becoming the key. This one and this one, which is 293. So these are the two major, this is where you're moving to reality now, into reality with these two. Hard to tell, but that FC is connected to that bolt on the ground right there. So, all right. Leaning over like this gives me a headache, but so I guess we're done for another day. I do not know. Okay, wait. I have to stop the stream.